fundamental concepts in software engineering, like different types of software, right? Software life cycle and so on. So from this week, we'll study much in details what we'll do in different stages. There are a few slides left. Last week, as we start late due to the internet connection or maybe MS Teams problem. So we were left somewhere here. Software engineering ethics. Okay. I guess that you guys know what this word means, right? Ethics means a discipline in which we'll study what behaviors or what actions are considered moral or ethical. What is wrong, what is right. Especially software engineering ethics is a kind of a discipline in which we'll consider what behaviors or actions we do with software is ethical or not. So we'll see the ethical responsibilities. Here we can say if you're going to develop a system, who are going to involve in the system development process? Software engineer, right? The developers, the users, the project managers, the leaders, the customers, investors, many stakeholders. All of them have their own ethical responsibilities. So when something wrong happens, we need to identify where the responsibilities locate. Honesty, for example, when a software engineer, when a developer, for example, works for this project, but he no longer works for this project, he quits the job and he joined another team who is also a competitor of the old team. Maybe I am taking the wrong example. Honesty. Alright, we can say like the developer must be always honest. Or the project manager, all of them, okay? So the honesty is the best policy in all areas or disciplines. Be honest to the project manager, be honest to your client. Client here means the customer who is asking for software, who is asking for a system. Remember the diagram I drew last week. This between the relationship between the customer and the developer. So I would use the word client to indicate the person or an organization who is asking for a system. The developer is the one who built up the system. Okay, that is like the protocol, okay, or a kind of a rule in our class. Like when we say client, we mean the one who is asking for a program, a system, software, a solution. And developer is the one who developed the system. based on what the clients required. Okay, sometimes you will see the word customer. So we are not doing something like business, like a restaurant has customers, or bookstore has some customers. No, not like that. In this course, you must play the role of a software developer who's going to program, to code, to build up a system. Okay, so you will do what your clients requires you to do. All right. So bear in mind the term customer and develop the client in such a way. Ethical behavior is more than simply upholding the law, but involves following a set of principles that are morally correct. So we have it here, not only the law, but also principle. There are some codes of conduct or codes of ethics in an organization that all the employees, including the developers, human resource staff, or whoever inside the organization, must follow. Okay, following a set of principles that are morally correct. Can you give me some examples of a moral behavior, moral action in normal life? For example, when we are on the streets, when we are driving on the road, for example, when we see the traffic light, when the traffic light turns red, you definitely stop before the red light. If it turns into green light, for example, if the traffic light turns green, you can go, right? However, at this time, there's a herd of ducks crossing the road, or maybe an elderly who's passing the road, or a handicapped person, for example. In such a situation, you must give the way for those to get across first. Then after they have crossed the road, you can keep going. So the first thing, when it turns red, you must stop, because that is by law, something you have to strictly follow, obey. The second case, when we are crossing the handicapped people or person or elderly, for example. So this is not by law that you must give way to them for them first, but you have to do it. Okay? Do you understand my example? Another example in software engineering, when you have the customers of the client's data, but you are kind of start a contract with the client, so you are not allowed to disclose the customer's data. So by law, you are not allowed to do so. However, in some cases, when the let's get back to the previous example I've just given. Like when a developer works for this team, but no longer works for this team, he quits the team and works for another team. Can he disclose some of the confidential or private information? Okay, I'm not going to tell you another story, which happened in reality. A person, let's say, he works for an organization A. He was the one who built up the system for student text entry, entrance test. Okay, the entrance test. He was the one who he didn't directly build up the system, but kind of the project lead. Okay, you know project lead, the one who leads the project. Then he quit this organization and worked for another organization. And you know, they are both educational organizations, so they are directly competing each other. Now he moved to this organization. He took the whole project here for this organization. So both of them are holding kind of the same entrance test system. This test is one of the key competitive advantage. The organization that first has this kind of test will attract more more candidates and then more students. So do you think that this action is ethically, morally allowed? Type your answer in the chat box, please. Do you think this action, this behavior, this action is morally correct or kind of allowed or not? Please type it in the chat box, your idea, your opinion. Think of answers here is Cẩm Thanh, right, is not morally correct. Tấn Vũ, I don't think that man should do that. Duy Tân, I believe it not. Hà Uyên is not moral. Tấn Vũ, he better sign some contract before quitting company A. Very good. So, if you think this is the case of this person, what if it were you? What would you do if it were you? let me know what you would do. If you quitted the company and you had all the source code for the text, what would you do? Source code, the code that can run the system. You have the code. You had the code. So would you, company B is asking you to do exactly the same system. Would you just use the code you had before? Okay, so this question is for you yourself. What would you do if it were you in this situation, in this very situation? What would you do? In this case, there is not much of the chance to verify whether the source code used in company B is the same as in A. You will have everything to cover up, right? So would you do so? Would you do so? Think carefully. If you have the source code, if you can run the system, you can make impression and you can be promoted quickly. Would you do it? I may say that there was no contract before he quit the first company. So I would like to hear from you guys. Thank you for your opinions. most of you here are showing your morality. Okay. Exactly. It depends on what belief you choose to cling on. Very good. Very good. Because here we don't have kind of any legal contracts. So it depends much on the belief of a person. Very well. Very good. I'm sorry. Very good. I can use the source code if there is no contract. If no contract, I think we can take that code and modify a little bit. Yeah. Opposition provided knowledge that can be applied to the new one. So we're not very good. Very good. So you see, in one situation, there are different ways. One else here, let me see. Team Phúc will use the basement and then develop further, right? And someone else will direct to another company who is not directly competing with that old company, Tấn Vũ. Okay, you don't know that policy yet. When he quitted this company, he left for this company. He didn't know that he was asked for the source code for this test. So I ask you another question. If it was August and the test must be implemented in September, so you have roughly only 1 month left, which means you can't develop the source code completely. Someone here answers that he will completely build from scratch or maybe modify a little bit. But let's say we don't have enough time. What would you do? We don't have enough time. Imagine like you have already the answer to homework in hand, right? You have the answer in hand. And the deadline is just tomorrow morning, okay, 8 a.m. for example, and it's now 12 a.m. You don't have enough time to build from scratch. You don't have enough time to write, for example. So what would you do? You see, there are many different cases because we are now here students, we are in a calming situation, and whatever we are saying right now doesn't really affect directly, I mean, the your salary, your income, your position, your job in general. So that means we are free to say whatever we think is correctly morally correct. However, when we are put in the real situation, probably you may change your decision. Okay, moral decision are affected. You may have your own belief as who said here belief, Hữu Bình. You may have your own belief. However, when you're put in a real situation, your ethic, your moral decision may be influenced, okay, by the environment surround, probably by your family members. You are, let's say, if you're in a normal situation, you will not steal the groceries, for example. But when your family members are put in a very severe case, a severe extreme situation, without the food for 10 days, for example. So in that case, you must change your moral decision. Understand? Okay, so that is quite an example, but it happened in reality. Yes. And we have no way to sue the person because there was no contract before. So there are some issues with the responsibilities here. The confidentiality, to keep the things confidential, like the customer's data or the source code, like in my not really the source code, the principle, the policies, the strategy of the company, and so on. So keep all of those kinds of information confidential. Competency. Competence here is like the skills. If you don't have enough skill to build up the system, better do not you better not or sign the contract to build up the system. Otherwise, I mean, if you don't have enough knowledge and skills in using the technology in building up the system in such an area, you may build a vulnerable system, a system that is insecure, and probably it doesn't satisfy the client's requirements. So you may lose the lose your brand image. I mean, your company's image. Okay, the process, something like that. Intellectual property rights. So as in my previous example, the intellectual property of the software, which belongs to company A, now is disseminated to B, for example. Computer misuse. Okay, you may use a computer for some other purposes. If you're allowed to configure the to fix the computer, for example, so you may access the manager's computers. You can access his private data. Okay, so that is not. What I mean is, like, when you are a developer, you may build up some. You may like install a very small code, source code in for example, here in this source code, okay, and we have very small parts which can bypass all the password, or can mimic all the password to access the manager's computer, for example. All right, so he can get all the private data here. Do you understand what I'm saying? Okay, as a developer, because the company doesn't know your client, I mean, has no or little knowledge in IT, in source code. So they probably don't know there is a hole here, a fault here, a mistake here, mistake by on purpose, okay, to get all the password that can access the manager's confidential information. Okay, so the computer is now misused. So as I mentioned before, we have some code of ethics and code of conducts in our software engineering discipline. We have ACM or IEEE. These are the professional societies in the US that have cooperated to produce a code of ethical practice for all the employees in one company to follow. So software company may use the code of ethics proposed by ACM or IEEE. Then they may have their own code of conduct. Okay, so the codes here has 8 principles related to the behaviors that only software engineers, the professional software engineers, like practitioners, educators, managers, supervisors, policymakers, students, trainees, all of them who are working for the software engineers must follow. So let's consider all the principles here. First, what you're doing there must consistently act with the public interest. That means you are building up something that are interest of the public and do not harm them. You are not building up a system that is going to explode and to harm the public. Client and employer, you must also have your responsibility to react, to behave responsibly. You have responsibility to act in the best interest of your client and employer. You would do what the client asks you to do, like we have to sign the contract with the client. If the client would like to have a system to manage the students' information, for example, so you should build up a system that can do what the clients required here. And when you work for a company, you also sign a contract with the employer, right? Okay. And so here in this case, the interest of the client and the employer must also be consistent with the public interest here. The two of them sometimes may conflict. And we don't know who we should follow, who we should listen to. Okay? Normally, if you are working for a software company, it's not that bad. That the conflict is not that bad. But when you work for a government, for example, or a big organization, international or criminal organization, for example, sometimes the public interest here may be inconsistent or may conflict with the employer's interest. If you work for IS, for example, IS organization, right? So totally completely conflict with the public interest. But if you are working for that organization, you must follow what the employer asks you to do. The next one, the product must meet the highest professional standards. The standards here may be security or the speed of response, okay, or encrypted data, and so on. Number 4, judgment. Software engineers shall maintain integrity and independence in their own professional judgment. So you guys are independent. You guys are acting like an independent agent when making a decision. You are free to make your own judgment, to make your own decision. As in the previous example, I asked you, what would you do if you were in such a situation? So for now, you are free. You are independent. You are free to make the decision that I will quit company B and work for another company who is not directly competing with company A, which I do think impossible. Why? You guys, if he was a project lead, so that means he is kind of expertise. He is kind of an expert in the area. Do you see what I mean? He is an expert in the area. So any company where he's going to work at must also directly competing with this company already. He can't just join another company where he has no knowledge at all. Okay, so in that case, he must he can't just quit for another company. Management. Software engineering managers and leaders shall subscribe to and promote an ethical approach to management software of software development and maintenance. So basically, it is like the software engineer managers and leaders must use an ethical management scheme to manage their team. Okay, it's just the way that people are working, people are behaving. For example, if an employee, if a team member is sick and he asks for absence, okay, but the leader say, no, you can't do so. We are running out of time. You can't ask for absence. We need you to work harder, for example. So that is not ethical, okay? Because the employee, the team member is now sick. Number 6, perfection. Software engineers shall advance the integrity and reputation of the professions consistent with the public interest. This is like when you are acting to increase the reputation of the profession, saying something like this. You are able to build up a system, a very well secured system, very quick response manner system. So you can increase the reputation of the profession. Everyone is now looking respect. Everyone now is respecting our profession, software engineer and software engineering. Okay, so when their children would like to choose a major, so they will say something like, "Oh, you should take IT major. Working as a software engineer, they are doing very well these days. They can earn high salary, for example." Number 7, software engineers shall be fair and supportive of their colleagues. So when someone is sick or someone is busy, you can make it up. Okay, you can take charge of their responsibilities. Number 8, software engineers shall participate in lifelong learning. Okay, lifelong learning, what I mentioned before, or maybe in the other class. Okay, whatever. You should have a lifelong learning skills and mind to keep sharpening your skills, your competence. Okay. And also you shall promote an ethical approach to practice of the profession. So this is mostly for you yourself. Okay, out of the 8 principles here, is there anything you guys don't understand? Let me know if you don't understand some of the principles here, please. Anyone else? Feel free to let me know if you don't understand any principle here. Okay, very good. You guys seems to understand very well. Thank you. So as I mentioned before, sometimes the conflict may arise between the, for example, you disagree with the policies proposed by the senior management or your team leader, for example. Your employer acts in an ethical way and releases a safety critical system with definition the testing of the system. Okay, for example, if a system is insecure, but he doesn't listen to you as an experienced developer, so it may have some safety critical problem. Participation of the development of military weapons, for example, or nuclear system, as I mentioned before. If you work for the governmental organization like military or NASA, for example, Interpol, for example, those systems require a lot of security and also some policy that may go against the public interest. If you studied engineering ethics with me, so you will see a lot of other case studies. But you guys are studying mathematics, so you are not studying ethics with me. Okay, I am running another course for engineering ethics. So we have a lot of things to do with the ethical dilemmas here. When an employee is facing an ethical dilemma, there's a conflict between the leader and the employee. What we should do? Okay, there is a framework, so a guideline. A guideline for the employee to follow the steps the employee should follow to whistle blow. Okay, to blow the whistle, or we say whistle blowing. You know the whistle? The whistle to blow. Whistle. I guess I am writing it right. Whistle. Right there. To blow the whistle so that the public will know about the situation and we can stop any safety critical problem here that may happen, that may harm the public. Okay, but that is much in engineering ethics, so I will not include it here in our lecture. Next, I will tell you some of the case studies of the system. Here, actually, the original lecture has 4 case studies. I think that's too long, so I just leave it here, 2 case studies. First one is a mental case patient management system called MenTCare. So basically, this is a system used to maintain the records of the people who are receiving care for mental health problems. Mental is something relating to your nerves, okay? Up in your head. Okay? And the second one is for learning online. Quite basic. This one is easier to understand, that's why I leave it here. So what does this information system do? It maintains the information about the patients and also the treatments that the practitioners give to the patients. Okay? The important information has been highlighted here, so you guys can catch up with the idea. Most mental health patients do not require dedicated hospital treatment, but need to attend specialist clinics regularly. Okay, and sometimes these clinics are not inside the hospitals. So we are building up a system to record, to maintain the information of the patients and also the treatments. So what do we do here in the MedCare system? We must have a centralized database. Database is a place where you store the information of the patient. Last week I asked you guys if you study database. Some of you answer yes, or maybe you are studying database this semester. So I hope that you will have a little bit knowledge in database management. So for example, in our university, we have a database to store the information of all students. Okay, first, and then the course that you are studying, and then the tuition fee, and then the lecturers. Understand? So we have a database here. What does that mean by centralized? Centralized means we have one single place for the database. There are many kinds of clinics. There are many clinics like this. Okay, they may be held in the local medical practices or community centers. That means there are many different centers here. But we only have one single centralized database from which different clinics can access to and retrieve the information. Okay? And of course, we must have a secure network access so that the different clinics can access to the centralized database here. It has also been designed to use local copies of patients' records so that it may be accessed and used from sites that do not have secure network connectivity. This means like when the connection is not stable, they may use their own local copies of the patient's record. For example, here, whenever when the connection is okay, that's why they keep getting the information and record, okay, the information and so on. Keep going back and forth. But if the connection is not good at all, so there should be a service to get the record of the patients down here to the local computer. Just leave it there. In case the connection is not good, the clinic here can use the record in this file as the latest information they can get. They update on this one, blah blah blah. At the end of the day, when the connection is good enough, then they will upload the information here back again. So the goals of this system is to generate the management information that allows the health service managers to assess the performance against the local and government targets. So we'll see whether the system is working well or not. Provide the medical staff with the timely information. This one is more important to support the treatment of the patients. So let's consider the different components in this system. We'll have different clients, right? Clients here are the clinic. Okay, this is the client server, model. Let me write it down for you guys. is a client-server architecture. The client will send requests to the server through the network here. Hey, can I have the information of this data of this patient? Then the server through the network can send back the record of the record of the patient. Okay. There are many different clients like that. As in our class here, you will play the role of the client, and me, I am the server. So if you want to be added into this class, you will say, teacher, can you add me to this class? And I say, okay, thank you. Oh, wait, I'm sorry. Okay, it's done now. You say thank you, for example. Or when you have to submit an assignment, okay, you will submit the assignment and I may acknowledge you, okay, I have received your assignment. Do you understand the word client here? It's not customer, okay? It's not the customer in business concept. It's the client-server architecture in software engineering. And here we have one server who plays the role as a host who can answer the questions from different clients. If we want to send back the data of the patient, I must go to my database here, looking for the data. After that, it returns the data and I have something to return here. Okay, let's say I'm looking for patient A. Okay, I know that. I go here and check the data of patient A. If there, okay, so I have record of patient A and return the record of patient A here. Otherwise, I will say there's no A in the system yet. So this is the organization or the architecture of the ManCare system. There are some key features of the system. The individual care management, it can create the records for patients, edit the information, and view patient history, etc. It also supports the data summary at the end of the day, so the doctors can quickly learn the key problem of the patient and give the proper treatments. Okay, always say the word prescribed. All right, the system can also monitor the records of the patients. The patient themselves can also see their own records. And from the perspective of an administrator, the system should be able to generate monthly management reports. So the hospital, the clinic manager can see the performance throughout the month. What about the privacy, the safety? All the patient information should be kept confidential. And there should be a function to warn the medical staff if some suicidal or dangerous patient case can happen. You know, something to do with mental, right? When you are stressed, when you are depressed, when you are desperate, you may do something that a normal person usually doesn't do. Okay, do you understand what I mean? So in that case, the system should be able to warn the medical staff so that they can hinder, they may delay, or they may stop the actions that may lead to suicide or any dangerous situation. The system must be available when needed to describe the correct medication to the patients. Okay, safety thing must be correct here. For example, if this person A has the prescription A, so the doctor must say the prescription, the treatment for patient A, not the treatment for B, for example. So things must be correct because this is something health related. Okay, that was the case study of the first system. The second one, for learning online, e-learning, or a digital learning environment. So this is tools for learning, and there may be some services chosen by the teachers and the learners. This system is service-oriented. Service here, again, is not service as in business concept, but in software engineering concept. When we run a program, when we run, especially when we run browser-based application, okay, browser-based, it's not the local or desktop. We may have different services, and the users are allowed to choose different services. Okay, we'll see the different services later here. But let me say, let me describe the system first. The system is a service-oriented system with all the system components considered to be replaceable service. So, as in the blog, you know, WordPress. On WordPress, you can choose different components or different gadgets or different service to be put on your website. You can choose this and that. Okay, let's say Blackboard, for example, Blackboard. Because we all are using Blackboard. So my page, my Blackboard page may be different from yours because I design my page in such a way. Here I have the component for modules. There I have the component for announcements. The other place, assignment for grading, for example. But you may have announcement, but you don't want to see the course list, for example, so we can just remove that part. Okay? Or me, for example, in Microsoft Teams, I can use, we all are using Microsoft Teams, right? So we should know about that. So in Microsoft Teams, I may use some service like Mint.io, for example, or some services for games, for example, for in-class activities. But the other lecturers do not use the same services as me. Okay, do you understand? So we can add different services or different components in on our page. This allows the system to be updated incrementally. So now we may have service 1, later service 2. After 3 months, when we're done, we add more services to the system. Okay, so we can update the system incrementally. It also makes it possible to rapidly configure the system, as we can modify the systems with different services. For example, here we have the system for young children, for senior students, because we have different environment, we have different versions, we have different services for different groups of users. What are those servers I keep talking about? Utility service. It provides a basic application-independent functionality, which may be used by the other services in the system. So here, basically, all the functions required to run the application. Okay. It's quite difficult to explain it right now because in order to understand the utility service, you may need to know further. Let me see. Like we must have an interface here, API, I mean, so that if you want to add further service, right, you must go through this interface. This is my system. You don't know my backend system. If you want to develop a new service, you must follow my service, my interface here. So that is one of the utility. Okay. You don't know how the organization is working, but if you want to register for something, you can use my form and input your information here. So I will check on your information. If it's okay, you will be accepted. Okay, something like that. It's just one of the utility service. Application services provide specific applications such as email, conferencing, photo sharing, and some access to scientific films or historical resources. Okay, so these are for basic applications. Configuration services to adapt to the environment and define how the services are shared. This is for the users to configure the system, configure their own application. So the architecture of this system is a little different from the MentCare system because we are doing the services here, so you can see there are different services. And this is a browser-based user interface, the browser that I mentioned before. Browser-based, that means a user who would like to use this system must have a browser like Chrome, Firefox, Safari, what else? Opera, for example. Okay. And then we have different services down here. Okay, interface as what I mentioned before, or we also have authentication, login, logout, to monitor what students are doing on the screen, to search, etc. Or some application like email, messaging, video conferencing, or configuration, how I want to run my own group, or identity management, for example. Okay. There are some other services here like integrated services or independent services. All right, so there are quite a lot of services, right? We can see that the two systems here have already got two different components, architecture. Okay, this one, it was like this because we don't really have the services, but we run the client and server architecture. This one is more on service oriented, okay? So we keep adding the services and the users are allowed to choose their own services. That brings us to the end of the lecture 1. I hope you guys all understand. Any problem? Any question?
No, teacher.
Okay, if not, then we may have a short break. Okay, we'll come back here somewhere around 12:15, 12:10 or 12:15, okay? Hello? You guys back there? Okay, let's keep going with chapter 2. In this chapter, we study about the software processes, or to be more specific, what we'll do in different phases. There are many different methodologies, but we'll study the basic one first, and then we'll get to know the different or the modern methodologies. Okay. What does it mean by software process? Software process is a structured set of the activities required to develop a software system. When we talk about the process, we have step number 1, step number 2, step number 3, and so on. And these are somehow interrelated and interleaved in sequence. Okay, and so these are the set of the activities required to build up a system. About the different activities we've learned last week, as far as I remember. Okay, so what are those actions, or what are those activities? Specification. In this phase, we have to define what the system should do. So, can anyone answer this question? What does Ment Care system do? Suppose that we have Ment Care system yet. If me as a client asking you guys as a software developer, I would like to build up a system to record the patients with mental health, mental problem. Okay. So guys, can you tell me what the system is going to do? Answer in the chat box, please. Store then and provide the information of the patients. Okay. What else? The key function is to store and provide the information of the patients. Good. What else? A place where different clinics can retrieve data of patients. Very good. What else? Ruben, you have an answer? Patients' information historical records, pull and push function for those information. Okay, good. Are they all? No more answer. Okay. When I ask you guys about the specification, you should answer something like the system should blah blah blah. For example, the system should store and provide the information of the patients. The system should be able to do something, okay? The system should be able to enable data retrieval, okay? Patient data retrieval, for example. We'll talk about the different functions of the system. That is what to be defined here in the specification. The next step is design and implementation. It is to define the system and implement the system. Okay, define the organization or the architecture of the system, as in the previous slides when we see the architecture of MenTCare and also iLearn system. We see the different components or the way information or the data are to be sent, okay? Then we need to validate the system to see whether the system answers the client's questions, whether the system can serve the can give a solution to the client's problem or not. For example, I would like to have a system to maintain the patient's data. So can the system now store the data of the patients? Yes, so it's a tick. But if something wrong with the patient's data, if I input the data, but the data is not there, the data are not stored in the database, so something wrong here. So it's a cross. The system must do what the customer wants. The customer here is a client in our sense. The next step is evolution, or to change the system according to the customer's need change. As I mentioned before, maintenance is not bad. It may be debugging, or it can also be enhancing or expansion. Okay, when the business is expanding over to another regions or nations, or maybe up to international scale, for example, global scale. So we have to somehow modify our system to cope with the business change. Okay, so in this case, the maintenance is enhancing. Software process model is an abstract representation of a process. So we'll have the description of a process, okay, or we'll see or the visualization of the process, how we are going to develop our software. In order to do the software process, we have to identify the products or the outcomes or the milestone at the end of the process. Okay, we must know the outcome or the result of the process. For example, after the specification phase here, we should have a list of all the functions required for the system. At the end of the design phase here, we must have the model or the architecture of our system, as what we saw in the previous slide. After the implementation, we should have a finished working product. After the validation, we must know whether the system is correctly built up or not, and so on. Okay, so we have the outcomes or the milestones. We also need to identify the roles or responsibilities of different people who are involved in the process. For example, during the specification, we need to know the customer's requirements, right? In this case, we must identify the role of the customers. Their responsibilities include letting us know what they want, and they should allow us to observe at their company, inside the company, for example, or they are responsible for to tell us about the document that they want to show on the screen, for example. Also, the responsibility of the business analyst here to understand the business process by the of the customer organization. Okay, in the design here, in the implementation, for example, here in this phase, the customer may not involve as much as in the specification because it is now the job of the developers. So we must identify the roles of the role of the developers. Inside the development team, we also need to identify who will work on component A or who will work on component B, for example. Project lead, business analyst, system analyst, developers, testers, and so on. Last, pre and post conditions. In order for a process to be executed, we need to check on the preconditions, whether the situation right now satisfies the preconditions or not. Or after the process, we need to check on the post conditions. That means whether at the end of the process we have got our outcome, or we are able to do some certain functions, for example. Okay, so precondition is before the process is going to be executed, and post is after the process is executed or enacted. Normally in the waterfall model, we'll do it like this. Step 1 to step 2 to step 3. Only after step 1 has been done and we have the products here, so we can move to step number 2. Otherwise, it is not complete. Is not completed yet. So the precondition for this one is not met yet. Okay, so we still are here. When all the thing here is done, then the precondition satisfied, then we can move to step number 2. Okay. There are basically in this slide there are two types of processes. First one is plan-driven and the second one agile. So this one is kind of quickly developed without really blend up. This one is for plan. We need a rigid, clear plan in order to process. This one, quick, as long as we have the product. Okay, plan-driven, all process activities are planned up and the process is measured against this plan. Okay, we need to know the progress, how many percent, whether we are on time, we are on schedule or behind the schedule or something like that. With the agile process, the planning is incremental. Get yourself familiarized with this word, incremental. So we are going to add further after a process, after each stage. Okay? It's like when you are reviewing for the exam, so you will do it incrementally. You will review lecture 1 first, and then next day lecture 2, next day lecture 3. Okay, sometimes you may go back to lecture 1 and review the different part that you left before. Okay, and then you go back to lecture 2, you get back to lecture 3 to cover all the things that you haven't reviewed before. Okay, so you understand this incremental word. And it is easier to change the process to reflect the changing customer requirements. For example, you are now you are reviewing chapter 1, and then maybe the next day, you haven't reviewed chapter 2 yet. The next day, I tell you guys, you don't need to review chapter 2. Okay, so you can remove it. Okay? Or in chapter 3, for example, you haven't reviewed chapter 3. But then on this day, I announced that you don't need to review this. Okay, so you just review this. Do you understand? Okay, so if the requirements from the customer change, you can easily change the process to adapt to the customer's change. Requirements change. In practice, we use both of the two processes. With everything, we need a plan anyway, okay? But we may not strictly based on the plan, okay? We just plan up basically like the rough time and list of human resources and so on, just roughly. And then we keep this one in mind to incrementally build up a system quickly. Sometimes we say that in agile methodology, we don't use any documentation as long as it can be quickly produced. So we just go with that without any plan or documentation. Okay, there's no right or wrong, depending on the nature of the system as well as the teams as well as the business. Okay, it depends totally on those aspects that we can use different processes. Software process models. As I mentioned before, you have heard of this term, waterfall. Okay, imagine a real waterfall, so it can only pour water from top to bottom. Okay, so we call it top down. So we can only do step number 1, finish step number 1, then we can move to step number 2. Otherwise, we just keep going with step number 1. And the phases here are separate. Not as in incremental development model, the phases are interleaved. Okay, something like this. Requirements are gathering, then analyze the requirement, design the requirement, go back here to get more requirement, then to analyze the requirement to design the system and a little bit implement, go back here, requirement, analyze, design, and maybe we need to design again. Okay, and come back here, design again, get the analyze and design again, so implement. We keep going. You see, the things are interleaved. But this one, we go from top to bottom. You see the difference? The model here, the two models here are different. Okay, waterfall is strictly planned up before the execution. But for incremental development, we can use both plan-driven and agile process. Next one is the integration and configuration. In this model, we are going to assemble the existing configurable and reusable components. Last week, we have come up with some of the reusable components. Of a system, there are some parts we can reuse. All right. Some of the parts have been developed before. Now we can configure them and put them all together. So we have the word here, integration and configuration. And this one can be blend up or agile. So of all of them, just only waterfall requires strict plan before execution. All right. The other you can do both of them. This one is like this. Put them all together. Configure them to make them a beautiful picture or a beautiful system. Understand? This is a waterfall model, and you can see it go back here, it go down here, down here, down here, and down here. This one is more flexible later on, but before we don't really have a go back here. The thing that if we go back here, it costs a lot. It costs a lot to go back. Okay, we need to redesign everything. And also we need to document everything back again. So the cost to do it back here is quite large, big, high. And the waterfall model phases are separate, and there are some drawbacks. It's difficult to change, it is inflexible, and it is difficult to respond to the changing customer requirements compared to agile. You see, we have to go back, we have to go down here, down. If something wrong, go back here again. Okay, and there is no place where we can go directly here. Oh, like this. But we have to go here and then here, strictly step by step, phase by phase. Okay, phase by phase. What about the incremental development? So we'll have, you see the outline here, and we have different phases or different versions. First of all, we'll have the initial versions so that the customer can or our clients can see the initial versions. For our team as well, to see the initial versions of the system. And then we add further, we have the intermediate versions. A lot of intermediate versions. Okay, and then we can develop the final versions here. You see it back and forth, 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 and back and forth. So this one is quite flexible. Until you validate your system, then we have the final version to be deployed on the client's side. Incremental development benefits compared to the traditional waterfall process. It can reduce the cost of accommodating the changing customer requirements. As you can see here, if you want to change, you have to go back here, up here. So quite a long road, right? And it costs a lot of money. Compared to this one, if you need to do something, okay, I will just go back and forth here, back and forth here. So the road is way shorter and hence the lower cost. It is easier to get the customer feedback. You can see at the beginning when we have almost nothing, but we have got the initial version already. So the customer can give us some feedback. Or even here with this one, the customer can give feedback. The customer can also give feedback here. When we have all the feedbacks here, so we can develop the final version and validate it so we can have a final version. So the customers can get more involved in the system development and they can give us more feedback. And with the incremental product development, we can look for more rapid delivery and deployment. As you can see here, we can have the versions here quite quickly. Okay, but for this one, down, 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 and down, and down. Just now we have the system ready. Okay, so it's quite a long time and rigid. There are some problem with the incremental development anyway. You remember there's no right or wrong process. There's no right or wrong process. The managers need to regularly need the regular deliverables or milestones or outputs or the outcomes or the products or interim report or whatever to measure the progress, how much of the process, how much of the project has we finished. And if a system is developed quickly, it is not cost effective to produce document because we need to go back and forth and create the document and change the document and so on. So in this way, the documentation is not really the key point as in the waterfall model. System structure tends to be degraded as new increments are added. Okay, so for example, we have this here, and then we add further. So the core here may be somehow degraded. Okay, when we add further, because when we are here, we don't know how we are going to add the new one. So we design this one for this one only. After that, we see, oh my God, I should have done something else. Okay, so the structure tends to be degraded. Reused elements may be configured to adapt their new behaviors and functionalities to users' requirements. Okay, so this one is for integration and configuration. Reuse is now a standard approach because you can see that fewer and fewer systems are new these days. Somehow they are similar. For example, a system for students to see to register for courses, to see the timetable. So every university is using kind of the same system, right? They must be modified to adapt to each university policy for sure. However, somehow they are still similar. Like students should be able to log in, students should be able to see the timetable, students should be able to register for the courses at the beginning of each semester. Okay, so why not reusing the system or the components that have already been developed? As in my ethical case study, I told you guys, whether you will reuse the system, some of you answer, I will modify it. Okay, so here maybe you can think of reusing or configuring the system to adapt to the requirements. Of course, this is legal. Okay, like we have different components developed by us, our software company. So I can use this one for a different system. Okay, do you understand what I mean? If we have the key on the keyboard, for example, so I can assemble the keys for different keyboards for different laptops. But anyway, the core is those keys. That kind of thing. There are some types of reusable software like standalone. We call it commercial off the shelves. Commercial off the shelf. Shelf, as in bookshelf. Okay, so you can imagine the shelves here are the shelves on in a bookstore. Okay, in a shop. So the application system is already developed and it is sold as what it is. No configuration, no add-in, no plugin, something like that. The second type, a collection of objects that are developed as a package to be integrated with a component framework such as .NET or J2EE, for example. Okay. So these are the package to be integrated here on this platform or framework. So the developer can reuse. Then last one, web services, as in the iLearn case study I mentioned before. Okay, so these web services are developed according to the service standards and which are available for remote invocation. So the Amazon, for example, Amazon is a company who offer a lot of web services that the developer can reuse. Okay, like a search service or crawling service to get the data at the end of the day service, for example. A lot of services offered by Amazon. This is the reused oriented software engineering. Okay, so we discover the software, we evaluate the software if something we can reuse, and we identify all the components that we can reuse from the other places. And we have the requirements refinement here. After that, we can configure the system and add more components or adapt the components. Okay, adapt components or develop new components. Both of them together to be integrated, and then we have the system. Understand this one? The advantages and disadvantages of using the reuse software engineering. We can reduce the cost and the risk, definitely. It's already there. Why not just use them again? Let's say if you're going to make a birthday cake, if you if the core of the cake is already made, okay? So you just go to the supermarket and buy the core of the cake and whipping cream, for example, you bring both of them home and you can whip the whipping cream, put it on top of the birthday cake and put some strawberry or chocolate decoration on top, and that's it. So you have just reused the core of the birthday cake and configure the top of the cake to make it for your friend or your family members and so on, okay, or for your love. So you can reduce the cost and the risk of the materials, okay, the risk of throwing away the materials or the risk of being ill from eating your birthday cakes, all right? And in that case, it can be fast. It can be delivered fast, okay? Like you just go to the supermarket, 30 minutes, and then decorate it, another 30 minutes, in 1 hour, you have things done. But if you make the birthday cake from scratch, it may take you like 3 hours with a high risk, right? But sometimes reusing the components or the system may not meet the real needs of the users. Get back to the birthday cake. If you want to make a birthday cake in heart shape, okay, a heart shape, I guess that there is no core birthday cake in the supermarket comes with a heart shape, mostly round shape, okay? Mostly round shape. In that case, you have to go home and cut into a kind of a heart shape. What about you would like to have it thick and strong enough to put the fondant on top? There's no such things in the supermarket. Okay, so in this case, you need to make another birthday cake. You don't have the control over evolution. Okay, as I mentioned, if you want to make it stronger or higher, you may need more layers of birthday cake. Okay, so in that case, you can't make it bigger. You can't make it stronger. Do you guys understand my example? Let me know if you understand my example, please. Come on. Everyone, understand my example with the birthday cake. Yes, I understand. If you don't understand, feel free to tell me. It's fine. Anyone. It's fine. Okay. Yes, I think you mean you understand, okay? In English, when you answer yes or no, it's different from our Vietnamese, okay? When I ask you something like mấy em có hiểu không? Mấy em không hiểu đoạn này hả? Thì mấy em trả lời là dạ. So in English it's yes, but in English it's yes. That's yes. It means you understand, okay? Because you don't say something like yes, I don't understand. We don't say so. Yes, I don't understand. We don't say so, okay? We say yes, I understand, or no, I don't understand. So I don't know whether yes here means what in which case. Okay, so I would take yes here as you understand. The next part is about the process activities, but we run out time, so I'll leave this one for next day, okay? For now, you guys, please answer some of the questions so I can make sure you guys understand the lecture today. Tell me different types of reuse software, please. Reusable software. Just type whatever you understand. Or you can turn on your mic. What does cards there on the board mean? Okay, type in the chat box or unmute your mic for a quick response. Quickly. Okay, answer Nguyễn Hà Uyên, commercial off the shelf, correct? What does that mean, Hà Uyên? No answer from Hà Uyên. Can anyone help? What does cost a commercial off the shelf mean? That means the components or the part of the software is already sold in the market. Okay, it's already made. It is made available and everyone can buy and reuse it for their own system. Correct. Can you tell me the drawback of the incremental development process? Okay, very good. You guys please let me know your understanding. Okay, I'm not grading, but I need to know whether you guys understand or not. So you may make reference on Google, but make sure you understand it and answer in your own words. Tell me the drawbacks of incremental development process. The cost will be higher. Not really. Okay, any other idea? I will explain later on about Teng's answer. The points are on the board, guys. Just type whatever you think. I just want to make sure you guys understand. Otherwise, I can re-explain. No, don't. Never mind if you misunderstand it. Show me you misunderstand it, so you won't make the same mistake in the exam. There is only one drawback. The cost will be higher. What about the other people, please? Bùi Tố Mai, Anh Thư, Hoàng Vân, Hoàng Văn. Please answer the question. What are the drawbacks of the incremental development? I guess Bình doesn't understand he's saying. Rồi, cái chỗ này có lẽ như các bạn cũng chưa có hiểu hay sao á. Câu trả lời chậm quá. I can't hear you clearly, must because of... Okay. Rồi, cô giải thích lại cái đoạn này ha. Hồi nãy bạn Tân nói là cái giá thành nó cao á, không phải ha. Cái giá nó cao á chỉ trong cái việc là phải viết ra cái document thôi. Document là gì? Document là một cái tập tài liệu để mô tả lại cái hệ thống. Các bạn hình dung như là khi chúng ta xây dựng một ngôi nhà thì chúng ta phải có cái bản thiết kế. Bản thiết kế cả về mặt cấu trúc nhà lẫn cái đường đi dây điện, đúng không? Điện nước, đường ống, tất cả các thứ lẫn ở phía trong của cái tường nhà mình á, thì mình phải có cái sơ đồ, thì để tới hồi mà mình cần mình xây dựng lại á, mình chỉnh sửa thì mình có cái bản đó mình mới biết được. Đó, thì các bạn hình dung như cái document, cái chỗ cô gạch chân màu đỏ á, cái document đó có nghĩa là một cái tập tài liệu ghi lại những cái thiết kế của cái hệ thống, để sau này khi mà mình mở rộng cái hệ thống hoặc là mình debug á, mình chỉnh sửa á, thì mình biết được cái này nó nằm ở đây, cái này nó nằm kia. Được chưa? Thì cái giá mà phải bỏ ra để làm cái document thì nó rất là cao. Nó cao ở trong cái điểm đó chứ không phải là cao để mà produce nguyên cái product ha. Rồi, bạn Vũ có vẻ nói đúng đó. Nè, ở đây á là tại vì là mình cứ phải đi tới đi lui làm những cái version rất là mới liên tục, mà không lẽ mỗi cái version mới này mình lại viết một cái document mới. Đó, thì cái ý của cái câu này ở đây là như vậy ha, chứ không phải là nó bị tốn cái giá thành cho cái việc sản xuất ra. Tại vì đôi khi với cái phương thức này nè thì mình sẽ đưa ra sản phẩm nhanh hơn cả waterfall nữa ha. Cho nên là cái giá ở đây chỉ có đơn giản là đối với cái việc là làm document thôi. Rồi, còn một cái vấn đề ở đây nữa là cái cấu trúc của cái hệ thống á, thì đôi khi nó không có được hoàn chỉnh. Ví dụ như các bạn hình dung các bạn đi chơi, các bạn chơi cờ caro nè, chơi cờ vua nè, chơi cờ cá ngựa nè, mình không chơi cá ngựa chơi cờ vây nè, thì các bạn đi cái bước số 1, các bạn đi bước số 2 thì các bạn có thể hình dung tới bước số 5, nhưng đâu biết được là số 3, số 4 nó có thể thay đổi, thì cái bước số 5 nó cũng sẽ thay đổi ha. Thì cái structure của mình, cái strategy của mình lúc này nó sẽ bị thay đổi. Đó, các bạn hình dung như vậy cho dễ hiểu nha, để dễ hiểu. Đôi khi cô đưa cho bạn những cái ví dụ để cho các bạn dễ hiểu thôi, chứ nó không có liên quan gì tới cái ngành môn học hết trơn á. Ví dụ như hồi nãy cái bánh sinh nhật á, nó chả liên quan gì tới software của các bạn hết, nhưng khi cô đưa cho các bạn một cái hình ảnh bên ngoài á, gần gũi với đời sống của các bạn, thì đôi khi các bạn dễ hiểu hơn ha. Là cái bánh sinh nhật chẳng hạn, thì ở đây hai cái ý cuối á ha, thì các bạn cần một cái bánh sinh nhật hình trái tim, bây giờ không có, ở ngoài nó không bán hình sinh nhật nào có lõi mà hình trái tim hết trơn á. Cái lõi thôi nha, cái lõi gato thôi nha, chứ không phải là cái bánh hoàn thiện bên ngoài nha. Tại vì mình đang nói về reuse mà, mình sử dụng lại cái lõi cốt bánh người ta đã làm sẵn. Thì bây giờ bạn mua ở bên ngoài hắn chỉ có cái hình tròn thôi, thì bạn về bạn phải cắt lại là tạo thành hình tam giác, hình trái tim, đúng không? Rồi, ví dụ như bạn muốn không phải là quét bơ, quét kem lên, mà bạn để một cái miếng nặng lên chẳng hạn, một cái mẫu nặng lên chẳng hạn hả, thì các bạn cần một cái cốt bánh á, cái lõi bánh nó phải mạnh hơn, hoặc là bạn cần nhiều lớp, bạn cần cao, nhưng mà ở ngoài nó bán thấp tiệt à. Đó thì là bạn bị mất cái khả năng là mở rộng cái bánh lên, đúng không? Thì cũng như vậy, tương tự như vậy. Bây giờ chúng ta coi cái bánh là cái phần mềm á, kiểu là như vậy ha. Rồi mình hỏi 2 câu mà thấy các bạn có vẻ trả lời không đúng hết nha. Thôi được rồi. Nhưng mà theo lời các bạn thì các bạn có vẻ hiểu. Các bạn nói các bạn hiểu, mà khi mình hỏi lại á, mà thậm chí là mình show lên màn hình luôn á, thì các bạn lại vẫn chưa trả lời đúng hết được. Thôi không sao, mình từ từ mình thẩm thấu. Slide vẫn sẽ được up lên Blackboard, có gì mình cứ thẩm thấu từ từ ha. Hôm nay bạn Lộc có học không? Lộc ơi.
Dạ có.
Lộc ơi, Lộc à.
Dạ có, em ơi cô.
Đó. Trần Văn Lộc. Không có luôn.
Yes teacher.
Bạn này đòi là phải có slide trước buổi học thì cô
Ôi,
mới trả lời.
ơi, nãy giờ bạn Lộc có trả lời rồi đó mà hình như cô không nghe hay sao á cô?
Bạn Tuấn Kiệt đang nói hả?
Dạ đúng rồi. Nãy giờ Lộc có trả lời á mà hình như cô không nghe cô.
Vậy hả? Tại vì cô tắt âm thanh. Lộc có mặt biết hả em? Không có. Xong cô mới trả lời là thường mà cô đưa slide trước cho các bạn á, thì các bạn sẽ không có tập trung vào việc học. Cho nên là cô sẽ xem xét thử, nếu như mà các bạn không tập trung á, cô đưa bài trước mà các bạn không tập trung thì cô cũng vẫn sẽ đưa slide sau buổi học. Rồi mình sẽ có đáp theo nhau ha. Rồi chúng ta có câu hỏi gì không? Any question? Hôm nay có rất là nhiều bạn tham gia vào buổi học luôn. Cô sẽ ghi lại ha, ghi lại các bạn đã tham gia vào buổi học. Ví dụ như một số bạn đây trong cái chat box của chúng ta nó vẫn còn ghi lại ha, thì các bạn sẽ có bonus point ha. Các bạn tham gia gọi là chủ động tham gia vào buổi học thì mình kiếm thêm được nhiều bonus point ha. Rồi, không có câu hỏi gì thì cô chào các bạn ha. Chúc các bạn có một tuần mới tràn đầy năng lượng.
Ôi cô.
Nói đi em.
Cái bữa thực hành đó cô, mình có code kiết gì không cô?
Cô intend là sẽ không có code, tại vì đối với các bạn á, code rồi mà phải ra được hệ thống hoàn chỉnh á, thì nó là cái câu chuyện dài dòng lắm. Nó đòi hỏi là các bạn có rất là nhiều background ở phía dưới nữa, nên cô sẽ tend là không có biết code mà là design nhiều hơn.
Dạ.
Được không?
Em tưởng là có mấy cái cơ bản.
Có muốn code không?
Dạ không, ý là một mình em á thì muốn, còn mấy bạn sau thì em không biết nha cô.
Ồ, code là mình sẽ code những cái ngôn ngữ gì vậy cô?
Java. Tại vì nếu mà code phải ra được cái hệ thống hoàn chỉnh đó, thì mình thấy các bạn hiện tại các bạn vẫn còn đang học database, rồi cũng chưa có được học Java, các bạn học C là chính rồi, nói chung là cũng chưa có hoàn chỉnh đâu tới đâu cả, cho nên là mình sẽ cho các bạn làm design nhiều hơn thì nó sẽ hay hơn, phù hợp hơn với các bạn.
Dạ.
Thường
Dạ,
các
nhưng
bạn
mà
mà
nếu mà cô có cái bài mẫu của cô, tức là ví dụ cô có cái code mẫu cô cho tụi em xem thử để tụi em mường tượng ra là cái code nó sẽ như thế nào hả cô? Chứ được không cô?
Code là cái hệ thống lớn luôn đó bạn. Ví dụ như bạn sẽ có nhiều cái classes ha. Ví dụ như bạn có Java thì bạn sẽ có nhiều cái lớp đó, rồi những cái lớp đó để thôi được rồi, để nếu mà, nhưng mà cô thấy cũng phức tạp lắm, tại vì để mà bày lại cho các bạn cái cách để code rồi. Tại vì đối với các bạn mà học IT á, để học được software engineering các bạn học phải năm 3 ha, là có nghĩa là năm 1 các bạn hãy học C, rồi năm 2 các bạn hãy học Java, rồi các bạn học web development, rồi các bạn học database đó, rồi các bạn học principle of programming languages, là rất là nhiều thứ trong đó rồi. Cô chào bạn. rồi các bạn mới học tiếp là xây dựng ra hệ thống phần mềm, cho nên là cái nền tảng nó mạnh nó mới làm ra được. Còn các bạn thì mình học toán mà, thì các bạn học cái ngôn ngữ code là để làm simulator nhiều hơn, cho nên là
Dạ.
mình cũng không hướng theo các bạn làm cái hệ thống hoàn chỉnh. Thì cái này thầy Quân cũng đã có thảo luận với mình rồi, thành ra là mình ý định là như vậy. Thôi
Dạ,
cô
dạ.
tắt lớp để cho các bạn khác đi học lớp tiếp theo ha. Rồi cô chào
Dạ,
các
dạ.
bạn nhé.
Bye bye cô.
Rồi chào các em.
Vậy là phải học OB trước thôi cô. Cô. Dạ thôi được rồi.